Hello, I'm Wayne Leck and I'm going to be doing AQA June 2013 paper. I'm going to go through the whole paper. This video is question 1, the rest can be found in the playlist on my channel. So if you're not there already, you can check that out. So, question 1, according to the examiner's reports, sort of mixed of who actually struggled with it at the time. It says that people who understood it gained the 3 marks easily, because these are quite easy marks if you know what you're doing. But some people got a little bit confused in what to do. So we're going to turn to the whiteboard and I'm going to go through question 1. So let's do that. So here it is, question 1 is a part A and a part B. Now firstly they've drawn 2 graphs, one of these I've done in green and one I've done in blue. And it says find the x coordinates for the intersection of y equals mod 2x minus 3 and y equals mod x. And the green one is mod x and the blue one is mod 2x minus 3. So we've got to find the x coordinates for the intersection. So firstly it's just the x coordinates, not the entire coordinates, but you wouldn't be penalised if you put the whole one, I'd imagine, but it does say x coordinates, so just to be safe. So modulus, you know that means that it could be a sort of a plus or a minus there, and if it was minus then the whole thing would become plus anyway, so the mod. So to know what we've got, if it's intersecting that and that, then y equals that and y equals that, then we can go ahead and equate the mod 2x minus 3 with the mod x. That's the first step. And most people are happy with that. Because you're finding an intersection between them, we can equate them. Now the question is, which of these is positive and which is negative and what's going on? So the mod 2x minus 3 is the blue line and the mod x is the green line. So where do they intersect? And they intersect when the green line's going up here. Firstly they intersect here at this point, and then they intersect here at this point. Those are the only 2 points it intersects, so we can expect 2 x coordinates. That's the first part. Some people equated them multiple times and got 4. That isn't right, there's only 2 intersections here. So it intersects on the positive arm of the y equals mod x, the one that's going upwards. It's got a positive gradient. Okay, so that's going to be positive, so it's going to equal x, and it intersects the blue line once when it's in the positive gradient line and once when it's in the negative. So this line going up here is a positive blue line, so we're going to keep the positive 2x minus 3 and make it equal to the positive x, because it's the positive arms of both. Then we rearrange, we take the x over that side to just get x, and the minus 3 over that side to get 3, and we get x equals 3. And now at this point as well, it's the positive one, so we don't put a minus in front of this mod, we keep it positive, but it's now the negative gradient arm of this y equals mod 2x minus 3. It's the one going backwards with a negative gradient. So we put a negative in front of the whole thing, and instead of a modulus, treat it as a bracket, sort of, with a minus in front. So we get minus 2x and minus 3, which is plus 3. Okay, so that's what happens there. Then take the 2x over that side because you want positive x, it doesn't really matter, but if I take the 2x over that side you get 3x equals 3, so we get x equals 1. So the important parts of that is knowing, firstly, that there's 2 points of intersection by looking at the diagram they're giving you, and then knowing to put a minus in front of this one because it's the one going backwards, and keep this one positive because it's the positive arm, and both of them intersect with the same positive arm here, so we don't put any jazzy minuses in front of the mod x. And there you are, you've got the 2 x coordinates, so that's cool. Part B, hence or otherwise, solve the inequality. The mod 2x minus 3 is greater than or equal to the mod of x. So firstly, the hence or otherwise. Now that really means you can do whatever you want. There's more than one method to do this. They don't want to see a particular method, but because it says the word hence, we know that somewhere in part A is information that we could use if we wanted to, and indeed I would. So what it means is, when is this graph, the mod of 2x minus 3, when is that greater than the x graph? Well, the blue one is the one that's 2x minus 3, and the green one is only the mod x, so it's greater than all of this area, and then it's greater than all of this area. And it's greater than or equal to, so it is including the point of intersections here. Now, what in part A can we use in part B? Well, we worked out these exact points of intersection. It's a point of putting which one's which, but 3 is obviously greater than 1, so this should be 3, and this one's going to be 1, because we know that this is 0 here. So now we know that it's going to be greater than the y equals x, mod x line for all of up to infinity beyond here. It's not going to re-intersect, it doesn't curve, it's going to be greater than it for the rest. So we can say that it's when x is greater than or equal to 3, when x is greater than or equal to 3, all of up here, then the mod of 2x minus 3 is greater than the mod of x. And likewise here, when x is less than or equal to 1, so that's all of this down to minus infinity, it's going to be greater than it for the rest of all that time as well. We know that this line coming up here isn't going to re-intersect with this line because this line is much steeper than this line. So that's how we know that that one's there, never going to intersect with that. And those are your two values. Now, you know they're two separate values because it's when is it greater than, and I've shaded the area. I would advise you do that in your exam. This area in between 3 and 1 is the other way round. The mod x line is greater than the mod 2x minus 3 line. So that's how you know it's two separate equality signs there, rather than x being in the centre and being greater than one number and less than the other. We know it's two separate ones. So this was a solid 3 marks, this was 2 marks, and that was 5 marks. And people who knew what they were doing gained all 5. They found it easy, because as far as these sorts of questions go, it was an easy question. But according to the examiner's report, there's a few people who simply didn't know what it meant. They were confused about the mod. They equated them 4 times, making these things minus and positive, when in fact there's only 2 points of intersection. So they didn't really understand the question. But if you understand it, that's 5 easy marks. Hopefully this video helps, and we'll get on to question 2 now. You can check that out.